Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. So we are going to discuss microcontroller and embedded systems lab. This is lab number 4. So in this lab we are going to interface 7-segment display with hex keypad. And in our tasks we have to make a hex keypad calculator, and we have to interface hex keypad with 7-segment display, and what we press on the hex keypad should be displayed on 7-segment display. So these are the two tasks in this lab number 4. So let me show you. So in the first task, we have to display the character from hex keypad on the 7-segment display. This is the AVR code. First we define the CPU speed, then we add the header file of AVR Studio, then we add delay file, then we describe the display function so that our input from the hex keypad should be displayed on the 7-segment display. Then we declare port A, B, C, D, E, and F as outputs. We are just using port A and port B, so no need of these ports. Then we initialize the higher and lower bits using unsigned character. This is basically a code for digital display. So we again open So this is basically the code to display any character from hex keypad on the 7-segment display. First we set the CPU speed, then we add the AVR header file, and then we use a display function to display the input from hex keypad on the 7-segment. Then we use the pin to num function to display the rows and columns of hex keypad to the 7-segment display. So these are basically the hex values for the numbers on hex keypad. So 0 has 0 cross 07, so 07 displays 0, and in the same way 0 0 it represents 1, and so on. And then on 7-segment display these letters display. We have basically see the data sheet, and on data sheet 3F represents 0, 06 represents 1, and so on. Then in the main function we use port A as output port and port B as output. And port A represents the rows and port C represents the columns. Then we initialize the rows and columns from 0. As it is 4 cross 4 hex keypad, so we are using a loop which runs for 4 times from 0 to 3. That's why we initialize it from 0 and it goes for 3. Then we check the rows one by one. As we press any character on hex keypad, so that row becomes 1. First we basically make all the rows one by one. all rows become high one by one, and then when we press any character on hex keypad, any number on hex keypad, then what is going to happen? The column of that row becomes one. So here it detects the column of the pressed key, and then we use the delay function. So then we use this function y is equal to log column divided by log 2 to convert the number from binary to this decimal number 3 to 1 and 0. And then we choose the value from the array to display num, and display num is stored to red, and this red is displayed to port B. So this is the code of our task one. Coming to its Proteus, let me show you. So this is the Proteus file in which we are using this hex keypad. These rows are connected to port A, and these columns are, as you can see, that these columns are connected to IO37 port C basically, and then this hex keypad is connected to IO53, which is port B. So now we are going to upload its hex file. So here we have uploaded its hex file. Now we run this code, and we can see that any character that is pressed on this hex keypad, this is displayed on the 7-segment display. I press 2 and 2 is displayed on the 7-segment display. If we pressed 5, 5 is displayed on the 7-segment display. So this is task 1. Now in our task 2, we have to make a hex calculator. So this is basically the code for hex calculator. So first we declare the CPU speed. These tasks are basically performed in group in our labs. So first we declare the CPU speed, then we add the header file, then we add the delay file. After that we make the functions. We use this display function, this pin to num function for rows and columns of 7-segment display, then this input num function for the input that is from hex keypad, and this calculator function which calculates. So this keypad functions, these are basically the hex for the numbers on the hex keypad 0, 1, 2, 3. We have seen from the data sheet. Then display function for 7-segment display, 3 or 4 hex values basically for 0, 0, 6, 4, 1 and so on. Then we initialize all the operands and the operator with result as 0. In the int main we declare these ports for rows, columns, A port, C port. These are for rows and columns. A port basically the output port, and C port for the input port. Then we declare port B and port D as output ports. So we initialize rows and columns from 0. This loop goes and this loops then for loop runs for 4 times. After that, the values from the hex keypad then changed into the decimal values. Then we use the delay function. So after that, it checks all the inputs, and in this calculator function, it checks the inputs and then gives the desired results according to the inputs. Like we have the division function, we have the multiplication function, subtraction, and addition functions. This displayed this stores basically the value in result, and then we display this result in display num, and display num is stored in ret. Ret is then stored in port B, and port B is the output port, which then displays the results. Now let me show you the Proteus of this task, task 2. So open project. So this is the Proteus. The rows are connected to port A, columns are connected to port C, hex, cell segment space connected to port B. Now let's upload the hex file. So we uploaded the hex file. Now let's check whether this calculator works or not. So the program runs. First we pressed 2. So the value 2 is stored in it. Then we pressed 5. The second value is stored in it. Then we pressed the operator addition, and you can see that 2 plus 5, 7, and 7 it's displayed on the 7 segment display. So this is about the Proteus. Now let me show you the hardware video. So this is basically the hardware video for the task 1, in which we pressed any number on the hex keypad, and that number is then displayed on 7 segment display. So here you can see that my group member pressed this 8, and then 8 is displayed on this 7 segment display. So this was all about lab number 4. For any query, you can comment below if you have any query. So this was all about our lab number 4. Thank you. Allah Hafiz.